Good morning. I'm Dr. Robert Seifert, pathology resident at the University of South Florida in Tampa, and I've had the pleasure of working with Dr. Marilyn M. Bowie of Moffitt Cancer Center on this project. It is an honor to be allowed to present at this conference. However, I regret I am unable to present in person today since I am attending the Osler Board Review course. This presentation was recorded on September 21st, 2015. I will try to be available by phone immediately after the presentation here at Pathology Visions 2015 to answer any questions you may have. Let's begin. My topic is an electronic atlas of epithelioid soft tissue tumors, a pilot for Pathology Atlas apps. We have no relevant financial disclosures. The goals and objectives of this presentation are to understand the practice gap between adopting whole slide imaging and its accessibility, to learn how our Atlas app template works, to learn how to download the Atlas template and add custom images, thumbnails, and diagnoses, and by the end of the presentation, you will be able to make your own Atlas web app. So why create an atlas? Simply put, an atlas is a collection of maps. However, I'm sure many in this room have used an atlas extensively when studying medicine and pathology. Traditionally, these are book-bound, but many atlases are in multimedia formats today. We believe better electronic pathology atlases can help address an important practice gap in pathology. Many practices have adopted whole slide imaging, but there are barriers to its use, including bandwidth, processing power, and accessibility. In general, whole slide images are not annotated, and conveying the important elements of a slide can be cumbersome. There is a need for a middle step between traditional microscopy and whole slide imaging, such that the important diagnostic information held within a whole slide image can be quickly and easily conveyed to an audience. Photographs can easily be taken of a whole slide image, organized into an atlas, and accessed quickly on an as-needed basis. An atlas running on a PC or handheld device can be an easy method of conveying critical diagnostic information. Applications include resident teaching, tumor board, and so-called curbside consults. How many of you have used or heard of this app produced by Johns Hopkins before? I found it to be incredibly helpful when learning cytopathology. It organized a variety of pancreatic cytology images by diagnosis and was easy to navigate. Most important, it was free. In decades past, pathology as a specialty was on the forefront of our digital age. We were the pioneers of the electronic health record through the development and implementation of lab information systems. Right now, it is our opinion that pathology is lagging behind. There are very few apps like Hopkins' app that can be used on a desktop or mobile device, either for daily practice or for pathology education. One of the first thoughts I had when using this app was, why aren't there more of these out there? At this conference, we talk about digital pathology and dream of the integration of whole slide imaging as the way of the future. How about we first carve out a way of the present? How many of you have a collection of photomicrographs on your computer, taken from things like tumor board, that you wish you could share with your colleagues or residents more effectively? I'm talking about photomicrographs, not whole slide images. You know, the photos that only take a couple of minutes to snap while you're working. The goal of our project was to develop an easy way to take these still images and get them out there in an easily accessible way. We developed a proof-of-concept Atlas app encompassing soft tissue tumors with epithelioid morphology. Our app also acts as a template, allowing pathologists with no programming knowledge to create an atlas of their own. We selected soft tissue tumors with epithelioid morphology because they represent a diagnostic challenge to most general pathologists, since they are seldom encountered and mimic carcinoma. This also made the design of our proof of concept more streamlined, since we had a small, focused group of entities to collect. So why do all this? Why did I program this atlas? People my age know that video games were always the thing that got in the way of studying. Well, this was my opportunity to take studying and video games and put them together. In the iPhone era, software design has become much more streamlined. Both iOS and Android devices have specialized development kits with which you can program your own software and publish to their app store with very little overhead cost. However, this route still mandates that one has a substantial background in software design and programming. Believe it or not, game design software has evolved to become more accessible than traditional programming. Two of the biggest integrated development environments for mobile game design are Unity and GameMaker Studio. Chances are, if you have a game on your iPhone or Android, it was made using Unity. Both of these IDEs are export platform agnostic. That means they can export their software to iOS, Android, Windows, Mac, or HTML5 as a web app. Both of these IDEs also require only minimal programming knowledge. Unity is not only the most popular platform, it is also the most expensive. Unity costs about $1,500 per export module. That is, if you wanted to make your software for Apple iOS and Android, it would cost $3,000 in addition to the cost of publishing to those app stores, which we'll talk a little bit more about later. GameMaker Studio, on the other hand, costs $299 per export module. So, we selected GameMaker Studio for our app. We also selected HTML5 as our export platform. This means that the Atlas can be hosted as a web app on any website. We would not need to go through and pay the developer fees for the Apple or Android app stores. This also dramatically increased the accessibility in terms of allowing the end user to modify our Atlas content and host it from their own website. More on this shortly. Here's what the design interface looks like. It may seem daunting to the uninitiated, but I have very minimal training in software design, and I found this very easy to use. There's an extensive drag and drop interface where you can just place objects, such as buttons, onto the screen, and the left-hand side shows the actual code, which is written in a pretty easy-to-pick-up scripting language. Using this platform, I designed Atlas software that can pull static images from a folder as they are referenced by a rudimentary relational database. Let's take a look at the front end first. The images we used were not actually traditional photomicrographs, but static images taken from Moffitt Cancer Center's whole slide image database. We have a virtual remote desktop suite that allowed me to access the whole slide image repository remotely and take still images from there. The whole process took only a few hours. From the main screen, you can choose to browse all images by diagnosis or choose to search through the results by a feature or keyword. You can filter the diagnosis list by clinical feature, such as age, gender, or anatomic location, or use a free text search within the description of the diagnosis. The Browse menu, on the other hand, has all diagnoses in the database displayed in a scrollable list. Both of the previous menus eventually take you to a gallery where thumbnails of the diagnostic images are displayed. Clicking on a thumbnail brings you to a larger version of the image. Here, you can read additional diagnostic information and continue browsing through your search results. It's all pretty simple, but what makes our platform relevant is that you, the end user, can download our template, take out our images and diagnoses, and put in your own. You do not need to have any programming knowledge. You just need to be literate in basic Excel and basic PC functions. I will now walk you through this process. If you go to TampaPath.com and click the Atlas Tutorial button, you'll find a copy of this video and a link to the Atlas template zip file. Download and unzip that to get started. The root directory of the template has an index.html document. If you are familiar with website design, you know this is the starting point of your website. Within this folder is another directory called HTML5 game. This is where the Atlas contents are stored. Within the HTML5 game directory are 4 additional folders. The ones that matter are the CSV folder. This is where the relational database is stored as a series of comma-separated value, or CSV files. The images folder, which is where the large form images are stored, and the thumb folder, which is where the image thumbnails are stored. Also note an INI file. If you edit this file, you'll be able to change the title of your atlas to whatever you want it to be. Let's start with the database, which is the CSV folder. The files in the CSV directory are all CSV files. They are all easily editable in Excel or similar programs. There are 5 tables. ClinFeet is a list of all possible age, sex, and anatomic locations for the tumors in your atlas. DXTable is a collection of all possible diagnoses in your atlas, along with their description. Feet table is a collection of all possible histologic features that may occur in your atlas, such as fibrosis or pseudogland formation. IHC table is a collection of individual IHC results for each diagnosis, and image table is a listing of every image in the atlas and its associated diagnosis. Now let's take a look inside the images folder. All images used in the atlas are JPGs, and all of them use a special naming convention that allows the software to load the correct image. The image names are 6 digits long, with zeros filling in the space before the number. Now on to the thumb directory. The file naming convention in this folder is similar to the images directory, except here all file names have the prefix thumb in lowercase. Alright, so how do you make your own atlas? You want to make your own atlas, so first you need to delete our content from the Atlas app. To do so, delete all the image files in the images and thumbs directories. Don't delete the actual folders, just the contents. Let's say for the atlas you want to make, you've got 3 JPG photomicrographs of alveolar soft part sarcoma. First, we need to resize these photos to about 1024 pixels in maximum dimension. This keeps them small so they don't overload the memory of mobile devices. To resize, I recommend a free and open source program for Windows and Mac called Image Tools. With it, you load the images you want to resize, then select Process, Resize, and select an output folder. Navigate to the project folder and select the images folder. In the prompt that appears, enter 1024 in the width box and select Proportional. Then click Resize. This will resize all the photos and save them to that folder. Next, we need to rename our images. The names of the JPG files is very important. A wrongly named file will not be displayed by the atlas. For renaming, I use another piece of open source software called Bulk Rename Utility. Open the image directory in Bulk Rename Utility. In the Remove box, increase the first N field until the file names of all files selected are just the .jpg extension. Next, in the number box, select prefix from the mode dropdown. Then, for pad, select 6. If you already had images in your folder and you wanted to add more, put the starting digit in the Start field. Now hit Rename to process the files. Next, we need to make the thumbnails. This is similar to before. First, load Image Tools again and select your newly renamed files in the Images folder. Now we're going to resize them to a maximum width of 224 pixels and export them to the Thumb folder. Now we're going to rename those thumbnails, just like the images, except for one thing. They already are numbered correctly, but now we're going to add the prefix thumb. Do so by entering thumb, all lowercase, in the Add box. Then rename these files. Now our images are ready, let's update the database. In the DX table CSV file, the first row has the header text for each column. Do not edit this row. Also leave the first column, which says My ID, blank. Under DX, type alveolar soft part sarcoma, all lowercase. For the description, I recommend writing a brief text entry in a word processing program like Word and pasting it into this cell. Do not use commas in the description, as that will cause an error. Instead, use semicolons. The atlas will replace them with commas when it displays the description. Clin feet 1 to 3 represents the most common age, sex, and anatomic location for this entity. For ages, I recommend using broad ranges or descriptive ranges like childhood or young adult. Clin feet 2, use male, female, or none. For Clin feet 3, use an anatomic location. For here, we'll say lower extremity. Feet 1 through 7 are histologic features like granular cytoplasm or a translocation like X17. You can leave these features blank if you want. Finally, for differential diagnosis 1 through 3, put items that are in the differential diagnosis. Now that we have added a diagnostic entity to our DX table, we need to update the feature and IHC tables accordingly. Open up the Clin feet table CSV. In order for searches and filters to work properly, every queryable item needs to be listed here. We only have one entity so far, so we'll just add that. Copy and paste exactly as you have it written in the DX table CSV, the age, sex, and anatomic location to the respective cell in this table. Next, open up the IHC table CSV file. Paste alveolar soft part sarcoma exactly as it is typed in the DX table. For alveolar soft part sarcoma, let's include two pertinent IHCs for now, TFE3 and keratin, under the IHC column. For the result, either use a plus sign, minus sign, NUC plus or minus, F plus or minus, or VAR for variable expression. Finally, let's update the image table. In the diagnosis column, paste the diagnosis text exactly the way it is worded in the DX table CSV. For image and thumb, paste the corresponding image number from our image folder. We had images 000001 to 3. We can just put 1, 2, and 3 for this. The software will add in the extra zeros automatically. Image text is any specific text you want displayed for that particular image. Mag is the total magnification as a number. And for stain, let's put H and E. If you used an IHC, then be sure to spell it exactly the same as it is in the IHC table. Now you're ready to launch the app. If you have a website, upload it to it and it will be hosted from there. This app is most compatible with the Safari, Chrome, and Firefox browsers. Now, you can use this video, the notes, and our template to make an atlas of your own. Once uploaded, this atlas functions on most new model phones, tablets, and PC or Mac computers. This provides the end user with a middle step between using a microscope and whole slide imaging for teaching and consults. It additionally aids the organization of pathology images. Finally, it was really exciting for me to tie in my extracurricular passions with pathology education. Thank you all so very much for your attention. It was an honor to be able to present here at Pathology Visions 2015, even if I could only be present digitally.